Hello. Now, say we are interested to find the acceleration of a rigid body when, say, this is a circular rigid body. This may be a disc or a cylinder, and this is the surface area on which this is standing. Now, if we are applying the force tangentially, that means, say, like in this way. So, we are applying the force tangentially now. This is the center. Now, we can, in this case, we can take the frictional force either towards the direction of the force, or we can take it backward to the direction of the force. So, in either way, the calculation will be same and you will get the same result. Now, how? See, suppose I am considering the frictional force is acting in this direction. So, in this direction, the frictional force is acting, which is small f. Now, for linear motion, the formula will be for linear motion. See, the two forces are acting in the same direction. So, capital F plus small f, these two will give, say its mass is m. So, these two will give its mass into acceleration. So, this is about the linear motion. Now, as the body is rolling, so for rolling purpose, we have to take the torque. Now, what's this? This capital F, this is giving torque, suppose in clockwise, and this small f, this is giving torque in just in opposite direction, that is in anti-clockwise. That means these two torques are in different direction. That means if suppose this is R, then this is also R. That means F into R. So for rotational motion or for rolling motion, F into R minus small f into R, that will be is equal to torque, that is I into alpha. So we have taken here minus because this torque is in clockwise direction and this torque is in anti-clockwise direction. So these two torques are in different directions, but this capital F into R, this should be greater. If this is not greater, then the body cannot roll in forward direction, that means in direction of omega. So that's why capital F into R, this must be greater. So from here we are getting F minus F, this is equal to I, alpha can be written as A by R. So I A by R. So this is coming I A by R square. So say this is equation number 1 and this is equation number 2. Now if we add equation number 1 and equation number 2, then this small f part will be cancelled. So we will get 2f is equal to, if we take common a, then we will get m plus I by r square. So a is equal to, that means the acceleration will be in this case twice of f divided by m plus I by r square. Now from the denominator you can take common m. So this will give you m into 1 plus I by m r square. We take this in this way because we know that I is, it will be in some form of m r square. So that's why we will get some value. So 2f by this thing. So this is the acceleration when tangential acceleration is applied. Now here the point is to be noted that when we are applying a force through the center, then the same thing is coming, it is like same, but it was only f in the denominator and in the numerator, and denominator was the same. So when we are applying this force tangentially, then we are getting twice of f divided by the same denominator. That means here the acceleration will be doubled. So in case of heavy loads, we wrap at first wrap this rigid body, that means a cylinder or something, and then we give tangential force. So in industry this type of force is applied when we want to bring about some things like heavy body, heavy cylinder or say drum. Then we wrap it with a rope, and then we give tangential force such that the acceleration becomes double. Now in this case we have taken the frictional force in the same direction that of the force applied. Now we can take it also in the other side, so it will not create any problem. See how. Suppose this is I have taken the frictional force in this direction, but now we will be taking frictional force in this direction. So let us take frictional force in this direction. So it will not create any problem, because actually we don't know in which direction the frictional force will act. It may act in this direction or it may act in this direction. So you can calculate in either way. So suppose you are taking F in this direction, and after calculation you get the value of F negative. That means you can understand the frictional force we have assumed it is in this direction, but it will be in opposite direction. And suppose you are calculating taking F in this direction, and ultimately the value of F is coming negative. That means you can consider that our assumption is wrong, so the F will be in forward direction. So it is not at all any matter. So in this case, the linear motion will be given by, see, the F is the only force which is dragging the body forward, and small f, this is actually F minus F. So this is small f is giving backward force. So these two will give mass into acceleration. And for rotational motion, now the thing that the capital F is giving clockwise torque, and the small f, this is also giving clockwise torque. Now both of these two forces, capital M and small f, both of them are giving torque in same direction. So in case of torque, these two should be added. So F into R plus small f into R, that will give I alpha, that is equal to IA by R, because alpha is equal to A by R. So here you are getting F plus small f is equal to IA by R square. So say this is equation number 1 and this is equation number 2. Now again, if we add 1 and 2, then this small f part will be cancelled. So ultimately you will get twice of f, and that is equal to, if we take common a, then m plus I by R square. So acceleration will be equal to twice f by m plus I by R square. So we can take common m from the denominator. So 2f by, if we take common m, it will be 1 plus I by m R square. So this is the same relation that we have derived earlier. So in this case in case of tangential force, when the tangential force is applied, you can take the frictional force, the direction of frictional force in either direction, so it will not be wrong. So ultimately you will get the same derivation, same formula.